Hey, what's up, app Morphees? Welcome back to the commute. And in this video, we're going to be discussing about inherit from the oops. Now, previously, I've already discussed encapsulation and the basic concepts of oops and what do they stand for and how do we use them. Encapsulation return in this video, we'll be discussing about inheritance, its example, and also an example of the production level code that we used in our day-to-day Android development. Let's get into it. Inheritance. Right. Now, what do we mean by inheritance? Let's just take an example of a class here. Like, this is a simple class, which is what we call a blueprint, right? Now, this is a class of type of vehicle, right? Let's just make a class like, and the class should always start with a V, which is means capital letter. Now, this class called another class called car. A car is a type of vehicle, right? So what we can do is actually inherit some of its function. For example, function dot engine, this function, which basically starts the engine, whatever vehicle we have. Okay, engine, my god, engine started. Okay, and what we do is just we inherit from the vehicle class. What does it say? Now, as you can see, we cannot directly inherit it because this thing is actually different in Java. We can actually inherit it in Java without any keyword, but in Kotlin, every class is private. So we need to specifically mention that we would actually inherit this particular class open. Now, when we use open keyword, what we are doing is basically telling compiler, okay, this class might get inherited, and we would change or override some of the functions that we use inside of this class. Simple as that. Now, what we can do is actually use the functions inside of it. It doesn't have override. Okay, let me just make a car object, car, right, car dot engine. As you can see, we have inherited all of the properties of the vehicle class, and now we can actually start the engine. So engine started gets printed here. This is engine started and it gets printed here. So let me quickly remove all of this and give you an actual example of how we are going to use inheritance shapes. This is the blueprint, all shapes. Now in these shapes, we have like circle, we have square. The circle and square are both type of shapes, and shapes is a blueprint that some of the properties of shapes will be inherited by both circle and square, but the circle and square are different from each other, but some of the stuff remains common, and that common stuff goes into shapes. That's how we plan our classes out when we are writing the production level code. They both calculate some kind of area, they both calculate some kind of parameter, right? So what we can do is write a function here, right? And what we're going to do is make a class here, a class circle. We won't have this super.calculator. Now let me give you a quick overview of this particular keyword right here, super. Super basically means that we are using all of the things that are written inside of the parent class that we are inheriting from. You must have seen this super a lot used in Android development, like in onCreate functions. So super is basically a keyword that tells you, okay, we are actually adding the functionality of our parent function into this child function right here. In this case, we don't need to do anything like that. We are completely overriding the function. And we return this and we get ourselves the radius, make it private. And of course, we will make another class called square. Right, so by our square, so we got ourselves shapes right here, two different shapes. We are calculating the area, and then we are making these functions open. With the help of this open function, we can override it and actually produce our own implementation of this thing. And the shape class is being inherited by both circle and square. Hopefully it makes sense. Now what we are going to do is make an object of square, a square dot calculate area. Now what will it print? Let's see, 16.0, which is correct. And SIR dot calculate area, and let's see what it gives. It gives us some 50.26 something, and this is how we calculate areas, and this is how we produce inheritance. It's pretty simple, and this is how inheritance works. Let me give you a description of inheritance. Inheritance is the principle of creating new classes from existing ones and reusing the behavior and properties of the parent class. In Kotlin, you can use open and override keywords to define a class that can be inherited and override its methods. Pretty simple explanation, right? This is how inheritance works in Kotlin. And now let me give you an example of real world production level Android development code. Now, hopefully you've seen what we call as view models, right? We have seen view models in Android development a lot, right? Now, what happens if there's a particular function or maybe some kind of event that we need to call every time in every view model that is present inside of our, basically tells us, tracks what kind of page he is using right now, right? It's this particular event, this particular API is getting called with every view model, and this particular event tracks where exactly is the user, right? You don't actually need to go and create events again and again and again. Instead of doing that, what we can do is produce some kind of common view model. Common view model would be the parent class, and it will be inherited by view models that are particularly used in a screen. For example, let's just say doctor screen. This is some kind of view model that inherits the common view model, and this particular event will be inside of this common view model, and the doctor screen view model will inherit all of these properties, and we can actually just call it and use it wherever we want instead of making the whole thing again and again and again. Hopefully this makes inheritance very clear to you. Hopefully you enjoyed it and added some real value. If it did, like, share, and subscribe, and thank you for watching. For now, bye bye.